All right. Ladies and gentlemen, my name is Gerald Toledano. I'm a partner of 8F Asset Management and a board member of Pure Salmon. Today we're going to talk to you about our blue entrepreneurship journey. We will make also some explanation about technicalities about how to address water sustainability in an aquaculture system. The mission of Pure Salmon is the transition toward more sustainable, water efficient, more local aquaculture. Our goal is to deliver with it a very efficient in terms of water consumption aquaculture, as well as an uncompromised level of animal welfare, and therefore addressing water resources challenges as well as the local and ocean resources. As my children would probably summarize it, happy fish, happy planet, and happy people. So now I'll project a video about our ambitions and about our goals.
Imagine a future of pristine oceans, a future in which we could enjoy the highest quality fish while looking after our planet and the generations to come. To achieve this, the world has to overcome today the crisis of supplying fish without further damaging and exploiting the oceans. The growing global population implies that current methods of supplying fish will soon not be able to keep up with the increasing demand from consumers. This means the seafood industry is in urgent need of an innovative and sustainable solution. Pure Salmon is leading a revolution in salmon production. Through land-based fish farming, we are committed to a future where salmon is produced sustainably. Pure Salmon uses recirculating aquaculture system technology, RAS for short, which means we can grow our salmon from egg to harvest in a fully controlled environment. We create healthy living conditions for our salmon and closely replicate the positive qualities of their natural environment. The water is constantly recycled and filtered to always keep it pure and clean, which ensures the health and welfare of our fish. Our land-based production process has no negative impact on the ocean's ecosystem, and our fish are grown using sustainable feed. The fully biosafe environment means our salmon are free from antibiotics, pesticides, hormones, and microplastics. Our educational centers teach new generations about the importance of protecting our oceans, the future of responsible food production, and the positive impact of pure salmon. The modularity of the RAS technology allows us to replicate our facilities in strategic locations around the world. With a global production target of 260,000 tons per annum, Pure Salmon is already on its way to become the worldwide leader in sustainable salmon production. In turn, we will have a significant positive impact on the health of our customers, our planet, the local economies in which we operate, while preserving the ocean's ecosystem. And we have already begun. Pure Salmon and 8F Asset Management are proud to be among the founding signatory members and supporting organizations to the Sustainable Blue Economy Finance Principles. These values and commitments are at the heart of our business, helping us shape a better future together.
Thank you. We established our global headquarters in the UAE, and we've also integrated one of the most renowned team of professionals to develop our own technology in water treatment and recirculation. We have above 2 decades of experience in this space, and today in Norway we help global and the world's largest farmer to grow for a longer period their fish outside of the sea, therefore preserving further and optimizing the resource of the ocean. Today, with our company, 10% of every salmon that is farmed in Norway comes and has been grown at some stage in their life in a facility that has integrated our technology. But we don't stop here. Our goal is to go full and entirely, as we say, egg to harvest, land-based. We want to grow our fish more locally, more sustainably, entirely outside of the ocean. For that, we are building fully vertically integrated facilities, including processing and and high value processing and usage of the offcuts that we produce. With this approach, we can unleash the potentials for a more sustainable food security system, for a less important impact on all footprints from the food business on Earth and in the ocean. For this reason, I'm going to hand over to one of our renowned specialists, Christian Ronning, coming from Norway, who is also going to give you his engineering lens to the challenges of trying to achieve water neutrality in the food system in aquaculture. Christian, over to you.
So, traditionally, salmon has been farmed by feeding the river through fish tanks on land, and then the water flowing back out of the fish tanks. And when the fish is big enough, he will be set out at net pens at sea. For this, the water quality in the river, if it's good enough for the fish, it will also be good enough for the fish in the fish tanks. We will use about 50,000 liters of water per kilogram of feed for this type of production. And in most countries, this is something that will be a water usage that's not sustainable. By is there a bit stuck? Try again. Yes, there we go. By removing particles like feces and food spill, and removing the CO2 from produced by the fish, and add oxygen, it can reduce the water usage to about one-third.
The feed on YouTube is not
By
working.
further removing
The sound on YouTube is not working
by
currently.
inviting bacteria into our system, we can
Not for him,
convert
not for
ammonia
his feed.
into nitrates.
People just
Ammonia is quite,
people texted me that people do not
neutral to the fish,
hear
and
it.
nitrate much less. And in this way, we can reduce the water usage down to 500 liters per kilogram feed, or 1/100th of what we started with. This is the standard technology today in most plants that are producing salmon smolt. So this is what a typical RAS plant would look like. It's a simplified sketch, and I won't go into any of the technicalities, but there are three things that we need to clean. We need to remove particles from feces and feed spill. We need to convert ammonia biologically and to nitrate, and we need to remove CO2 from the fish's breeding, and then add new oxygen before the water comes back in to the fish tanks. Then, for further reduction of water, we need to start removing nitrate, converting that to nitrogen, and maybe remove some phosphorus. And in that way, we can go down to 150 liters per kilogram feed. This is as far as the standard solutions have come today. And this is where our journey really starts. Moving from those highly closed recirculation towards a zero discharge, we have a goal of around 30 liters per kilogram feed producing fish entirely on land. And then the question for us is, what do we now need to look at? The first challenge we came across is really the definition of what is good water quality. For our standard systems, the water quality is known. We need to have oxygen for the fish. We need to remove particles, remove CO2 and nitrogen compounds for the fish to have a good water to live in. So what the question is now is, what next thing do we need to clean? Is it metals? Is it organic compounds? Are there other components that accumulate in the system as we now no longer bring water in, or very little water in and very little water out of the system? Naturally, we will go to the literature looking at what is good water quality for fish. Now what we see is that the values vary greatly. We have a lot of values that is categorized as non-toxic. And is that good enough? Every fish has a right to have a good and healthy water and a good and healthy life. And not toxic isn't good enough. We really need to have water that the fish can thrive in. What about all the components that are not listed? What about combinations, variations, and maybe we have some mitigating factors? And maybe these tables are not relevant at all because these are made for flow-through systems, river waters, and might not be really adequate to look at really closed systems. So this is the first challenge that we need to solve. Yes. And that is for the fish itself, but also, as I said, we have microorganisms that live in these plants. We have a small ecosystem where the microorganisms help us to treat the water, and they also have a lot of demands on what type of water quality they need to do their job. The next challenge is to identify what influences the water quality. In a standard solution of today, it's a lot about quantity of different type of inputs and having control of the main components. Going into a ultra-closed loop, we have to also look at all the impurities of the system that comes in, and any impurities, any other minor trace components, everything will accumulate in a system like this. So this is a very complicated mass balance that needs to be sorted out, and also to know how much is retained in the fish and is it coming out in particles or as dissolved. So what we have done in our thinking is we want the fish to have a safe and good life, so we are using known and well-proven technology for the primary water treatment, so that it's no surprises in the water that the fish lives in, and then we replace the river water and the seawater by treated water in the secondary and tertiary treatments. Both of these waters are influencing each other greatly. So we need the knowledge here to know how these affect each other. We also get some of these vicious circles. If you want to have a very low concentration of contents in the water, we need more removal. More removal means more removal stages, which also often means more use of chemicals. These chemicals have more impurities, which again demands more removal. So this is where we need to find a balance and the right level. So in this work, we have been working on this now for a year and a half. There are identified some knowledge gaps. The first one, as I mentioned, what is good water quality, and the second one is where do the different inputs go. And this is a task that is too big for us alone to solve. We have good partners, equipment partners. We have good connections with universities, doctorate, master thesis, and so on. But this is something that the whole business really needs to look into to make sure that this is a good and safe and a sustainable solution. So I think I will give back a bit to Gerald.
Thank you, Christian. So I hope that this short presentation has correctly, highlighted that for every climate challenge that we have to address, there is always going to be the necessity to invest into technology, into innovation. Obviously, the transformation of our food system is necessarily going to be capital intensive. We're very lucky to have been supported by some of the most prestigious investors. We have 4 sovereign wealth funds on our board and as part of our investors. We believe and we are advocates of this partnership between the public sector, the private sector, in order to change and to make the progress. We have to be particularly thankful to Abu Dhabi, the UAE, via the Abu Dhabi Investment Office, that has been a proponent, a supporter of our business in establishing our headquarters in the UAE, where I relocated recently, 3 months ago. We also have as an enabler the attraction of talent. We are lucky with our mission to have been able to attract people, talented people, diverse people, to join the cause, to believe in our purpose, and we have now more than 250 employees globally. And within the last 18 months that we established ourselves in the UAE, we believe the UAE has absolutely every advantages and necessary parameters, every necessary attraction to make and to take the goal as a world leader into food sustainability and aquaculture. And for that, our ambition is to become one of the largest fish farmers in the world in a sustainably and contained environment. For that, we will not compromise with our engagement of water efficiency, of circularity, and of energy footprint. We will target to have zero waste from food products and to be able to achieve the highest level our efficiency on the water we consume. As sustainable entrepreneurs, we obviously have to believe in scalability and efficiency. We have to believe in our ability to generate profit sustainably. And we can do that by the partnership of our investors, our stakeholders, all stakeholders, to the different SDGs to which we can have an impact directly. Ultimately, we still have a long way to go. We're still working tirelessly, people like Christian, his team, myself on the investment side. We're working tirelessly to achieve these goals, and we hope next year to be able to present you much further milestones, much further achievement, and we'll see you. Suspense. We'll see you in Dubai next year at the COP28. Thank you very much, everyone.